everyone, welcome to the Loop. Martin here. I wanted to talk to you a little bit about the Plinth, which is the Raspberry Pi little synth that I've built. I think you should watch Sam Battle's video. I'll put a link below about procrastination. This is procrastination from actually getting on with the cake video that I was doing. So instead of doing cake, I started playing with a Raspberry Pi Zero. My motivation was really to try and build something, actually like a data gathering tool, something that would go out and measure voltages and collect them over a number of days, and then maybe bring those back and create maybe some waveforms out of them. But of course I got caught up with my original code from the wave shaping and various other things, and I've turned it into a synth. What I was interested in was the ability to get hold of a knob, physical knob, and be able to twist it. Everything I've done so far has always involved some sort of slider on the screen or something like that, and those who live in the analog world have the ability to twist a knob, and when they twist a knob something happens, and it happens as they twist the knob. Sliding a slider up and down in the sort of graphical screen is just not the same. It doesn't have the same physicality or actually even the same effect. So what I've done, or what I had, was an analog to digital converter. It's a 4-channel one. So I can use the analog to digital converter to measure the position of my pots. And then I can use those inputs for changing the wave shape or whatever else I want to do. The other idea with this Raspberry Pi Zero was to try and keep it very minimal, so just to use a Bluetooth speaker. And the other thing I had in mind was to keep it entirely wireless, so you can have a wireless connection to it, stick a battery inside, and it would just work. I haven't actually mastered that part of it yet, because with 4 pots you actually need some switches as well to make it happen. You need something to actually kick off the process within the Raspberry Pi itself to make the program actually run. Also, without any kind of screen or user interface, which is what I wanted to do, I want to achieve something that's completely screenless. There's no way to pair up Bluetooth devices, and there's also no way to configure the wireless network. So as a device that you could give to somebody else, this is still slightly challenging. I wanted to talk really something about what it's done for me. I put this picture on Instagram. It's attempting to solder a very small wire onto one of the pots. When I was faced with this, I realised that the last time I did electronics, I did it with a passion when I was like a child, even sort of in my teens. I'm 50 now, or 50 plus. Now my eyesight isn't what it was, and my hands don't work as they did, and I've got to put the light on, and it kind of felt really visceral, kind of felt really important to be working with hardware again, because it's a long time since I've ever done it. It felt really satisfying, and there's some real challenges with trying to get this working. So in order to talk to Bluetooth, I did a lot of reading of forums. I need to use, when I write code, I use something called the ALSA, which is some sound library, but when I got it working with the Bluetooth speaker, there was like a 10-second latency. So you twist the knob, 10 seconds later something happens. So there could be a lot of Googling and find more stuff to find out the bug in the code that I had, actually with the sound driver, so setting the buffers the right size. So that actually got the Bluetooth working. Then I had issues with the analog to digital converter. I finally twist the knob and there was a huge delay, a huge latency. I'll draw a picture of that in a minute. So the night that I solved the problem with the latency with the Bluetooth, the night that I soldered the pots together, and the night that I fixed the analog to digital converter latency, I actually had a working instrument. I went to bed absolutely elated because it connected so much with my past in terms of doing electronics when I was young, and so much with what I do now, which is IT and software. It's just great to make noises, great to make sound. On the next part of this, I want to talk to Gareth Miller. I want to talk to PNP Modular. He's a proper modular synth person, and he's an expert at soldering and an expert at hardware, and I wanted to kind of get him on board with this. Really talk about the differences between my experience with digital and his experience with building analog synths and building modular synths, and what it is to do soldering, and I think there's a lot of mileage in that. So for part 2, let's see if we can get Gareth along to talk about, what between us, to talk about our experiences with this. I'll talk a little bit about the A to D issue I had and how I got around it, and then I'll show you a little bit of a jam with this thing, and then I'll leave you to it. And this is really my procrastination from the cake project. So I'll show you why I started procrastinating. Cake. I got slightly carried away with the ray tracing element of it. I wanted to make the light nice and realistic. So you can see here how it's going on. And I think this is why some strategic procrastination has occurred, because I've got a bit carried away with the lighting of the thing rather than actually getting on with the splurging of the cake. Anyway, enough of that. Have you all seen Frozen? I bought my Frozen crayons for this one. So I bought what I thought was a 4 quad input A to D. So here's my analog. Here's some interface which I know works with the Raspberry Pi. I think it's called a C2I interface. It's just a serial interface. So my assumption was that I'm just going to write some code here and I'm going to get my inputs. 4 pots. Do a little, like a nice, that around those. So 4 pots, something like this. That goes to there, that goes to plus volts, that goes to ground. Measure the voltage. I was really keen with this to get away from sliders to proper twist a knob, and for the frequency to change as I twisted the knob. And my first attempt was absolutely fine. So when I used one knob, I got a twisty knob and that was fine. But when I attempted to use all 4 knobs, I ended up in a great disappointment. Because what I discovered with the architecture of this chip is there's actually only one A to D in here. There's only one device that does the measuring. And then instead of there being 4, there's only one. And then here is some kind of multiplexer. So 1, 2, 3, 4. I'm really letting it go with this dragger, aren't I? So in the software on the A to D, you have to tell it. You have to say either continuously measure, which you set some bit, so continuous, or single shot. Single shot's annoying because what it has to do is you have to tell it, right, I want a reading. It says, alright, I'll go and get you one. It has a long think and then gives you an answer. So that takes a long time. Because essentially it has to set this switch, get a reading, and then give you an answer. Continuous, well, I'll have to use that. But if you use it in continuous mode, this switch is moving around. And what happens is, although it's moving continuously, you don't actually know which input you're getting. So when I used it in continuous mode, as I was twisting this knob, it was maybe what that was controlling would get changed, and then suddenly this knob would. So my frequency was going all over the place. It was a real mess. So continuous mode's no good if you've got multiple knobs, but single shot mode's no good because it takes too long. Just got to wait for that to get there and then so at this point I was extremely disappointed and disheartened by this piece of hardware, because for one knob it's fine, 4 knobs are useless. So what was the way out? Well, it occurred to me that actually, in reality, you only ever twiddle one knob at a time. So what I did in the code is I said, let's go in single shot mode, which takes time, and measure each knob. Right, get a reading. Next step in the code, have any of these readings changed? In other words, have I started twisting a knob? If they have, this one's changed. Once I know this one's changed, what I can do is put now this channel, into continuous mode. And all the time that it's changing,